This project challenge is called Pearl's Pancake Pad. The idea is the client is a small growing business and they'd like to upgrade their current pen and paper system for tracking custom orders and tickets to a digital point of sale system. And the student is being asked to design and build this point of sale system for them to meet some specific requirements. Those requirements include the fact that the wait staff is going to be able to input the table number and the number of diners sitting at this table with a maximum of 4. And then for each diner at the table, the system will display a menu of at least 7 common breakfast items, some drinks, some entrees displayed with prices. Students are free to choose their own menu items. And the wait staff will enter items that the diner has ordered for each diner, and each diner can order as many items as they want off the menu. And after one diner's order is taken, then the next diner at the table, their order will be taken, and so on. After all diners at the table have ordered, the system will display the before tax total and the after tax total for each individual diner with a sales tax of 8%. And it will also display the total with tax for the whole table and a suggested tip amount for 10%, 15%, 20%, and 25% service qualities. And finally, after the table order is complete, the program should restart at the beginning, waiting for input for the next table and its orders, unless the manager selects quit, at which point the system should report the total amount of money that should be in the register. That's the total tickets plus tax for the entire day. What we're wanting the students to work with and demonstrate knowledge of and ability to apply in this project is defining and using custom functions. So we want them to break this problem down into a set of steps that they can name and define a function to perform each of those steps. We want them to demonstrate the ability to use if statements to get the program to make a decision, and we want them to be able to identify some places in the code where we're doing some things perhaps more than once, and we can simplify that with loops rather than just repeating ourselves in the code. So for example, for each diner we display the menu and allow the diner to select items off that menu, any number of items they want. So that's should be an obvious place where students can use a loop. We want to do this for each diner at the table, so that should be another obvious use for a loop. And then we want to be able to input information for multiple tables throughout the day until the manager sets the system down at night. So there's at least 3 opportunities for loops here. We've got a list of things for the students to think about to kind of help them focus on what we're hoping they'll demonstrate. And then, of course, as always, there's a grading rubric. Most of this should be starting to look very familiar to you right now. The syntax component is really unchanged from prior project challenges. The correctness component is there as well, making sure that the student's code produces the correct outputs for given inputs. We have 10% for naming of variables and functions. We want these to be descriptive and appropriate. And then we are focusing on their use of decision logic. For full credit, we're expecting at least 3 decision logic structures, if statements, and at least 3 while loops. And of course, they get partial credit for anything less than that. And then with respect to user-defined functions, again, we're looking for at least 3, but I suspect we'll see quite a few more than 3 user-defined functions for most of the students, because they're starting to become comfortable with the concept of functions. And then as always, we have the grading aid down here with templated feedback that you can provide to the students in the event that they're not getting full credit for something. And then there's a target solution down here. So it's not the solution. This is just one way that we expect students might go about solving this problem. And you can use this to copy and paste to give some examples to the students if they might be struggling in areas. But let's go ahead and take a look at a couple of students' examples and see how their submissions are graded according to this rubric. So here's a student here. Usually the first thing I like to do when I'm grading this stuff is check to see what the automated grading system spit out in the report. So here we see it passed syntax tests, the code compiles, It passed the input and output tests. There are 4 decision logic structures, which exceeds the 3 minimum. There are no loops in this student's code, so they're going to get hit on the rubric there. And there's a little note here telling the student that they're missing loops. They have 8 user-defined functions, which is more than we asked for. They got a 5 out of 5 on the auto grader for inputs and outputs, a 20 out of 20 for decisions, a 0 out of 20 for iteration because they have no loops. The syntax is good, and the user-defined function count is good. The remaining criteria we would have to grade manually, and this one has already been graded. And let's take a look at the code really quickly. So the first thing I see is a lot of function definitions, which is good. This is a good sign to me. And looking at these functions, one to display a menu, one to collect input for a diner's order and return the cost, one to display the cost, calculate the tax, total cost, display the cost with tax, a tip calculator, cost with tip. This is not bad, and their naming conventions are looking pretty good. So I don't see a problem there. The big problem is they didn't use any loops. So I'm concerned that the student is struggling with this concept of loops, or at least with when and how to apply them. So let's see what the grader wrote in the comments here. You did a great job of breaking this problem down and designing and writing separate functions to solve each part. I agree with that. Most of these functions are pretty small and flat, and that's a really good sign as well. However, you did not use any iteration logic in your program. You may need to review this section of the course to be sure that you are comfortable designing and writing programs that easily repeat useful steps. Remember that loops are how we get a program to do something more than once, so look for places in the program where we might want to do something more than once. For example, inputting the menu items for a customer, or inputting the whole order for a table. These are pretty good comments. I'm going to go ahead and save that small change. And then you see that the points assigned according to the rubric, full points for syntax, correctness of input and output. There are some problems with the behavior. Without the loops, their program is not behaving the way that it is described in here, repeating the order of multiple tables on request. So not full credit for the correctness of the behavior. The naming is solid, the decisions are good, they're light on the iterations. This is according to the rubric as well, 4 out of those 20 points, which is the minimum. So a 2, but that's 20%, so 4 is the equivalent number of points that we should give for that. So that's correct. And their total score is a 74, which is not bad. So the feedback is highlighting the positives and encouraging the students to continue doing the things that they're doing well, and then pointing out the most significant areas where the students can focus to improve the most on this assignment and subsequent assignments. So let's take a look at one more example student submission. Again, I'm going to start with the auto grading report here. Again, this one passed the syntax tests and compiled. The inputs and outputs look good. Student is using 16 decisions and 2 loops, which is 1 short of full credit, but still pretty good. 11 user-defined functions, and the auto grader gave them full credit on just about everything that it's capable of grading except for the loops. They're missing 1 loop that would be necessary for full credit. So let's go ahead and take a look at the student's code. And again, I see a number of functions defined here. These first few functions are nice and small. There's a big one here that adds item costs. This one's a little meaty, but it's not too bad. This one calculates the order, and it has a loop inside of it. This one, what does this one do? Diner number. You give it a diner number. This is a strange one. Okay, so this is just making sure that the diner numbers are within the range of the number of diners that are able to sit at a table. This is a little bit crazy. A method that the combination of arguments. So I would consider making a comment about this method is possibly trying to do too many things at once, and it might be worth breaking this method down into some simpler methods so that we don't have to pass quite so many arguments to such a function. And again, some of this stuff gets pretty complicated, so I might make a comment about that. Let's see what the grader who graded this actually said. Overall, excellent work. Good use of iteration logic to get your program to easily repeat useful steps, but you did miss at least one opportunity to enhance your program with iteration logic. For example, you could use a loop to simplify the code where you are calculating the individual totals and adding them up to get the table total in general. Anytime you see a significant redundancy or repetition in the code, you might be able to simplify this with a loop. So I think this is one way that the grader is referring to some of these really thick functions with a lot of repetitive code in here. I would just add, you know, the idea that you can take a look at some of your functions that have a significant amount of repeated code. Some of these functions could be simplified by using loops. And then I'll go ahead and save that. Other than this, the student scored a 93 out of 100, which feels appropriate and follows the guidelines and the rubric. So there's a couple of examples. As always, it's a great idea to start the grading by reading through these projects, and one really good pro tip is if you want to do a really good job of grading these, then the first thing you should do is attempt the assignment yourself, and that will give you a really good sense of what the student is going through when they're trying to solve this problem and where they might get stuck.